Okay, so we got a word problem. Penny and Sheldon are assembling hair clips. Penny can assemble a hair clip in 6 minutes. Sheldon takes 9 minutes. So let me underline these here. So 6 minutes and 9 minutes. If they start making the hair clips at the same time, hold on there 1 second. There we go. If they start making the hair clips at the same time, what is the least amount of minutes it will take for them to finish the hair clip at the same time? So my screen's kind of freezing there. There we go. Yeah, so there we go. So there's our question. What is the least amount of minutes it will take for them to finish the hair clip at the same time? So what we could do is we could draw a diagram. And we could say, okay, here we go. I'm going to make a little diagram here. And start them off here. And I'm going to say, okay, this is going to be, who do we have? Penny. Penny up here. Penny gets one done every 6 minutes. So I could go like 6 minutes and 12 minutes and 18 minutes, right? This is Penny's first clip, second clip, third clip, right? So there's Penny every 6 minutes. She's working at some kind of assembly line. Every 6 minutes, she gets a hair clip done. So she gets her first hair clip done at 6 minutes, the second at 12, the third at 18. Then I'll come down here and I'll do, who's the other person? Sheldon. Sheldon takes 9 minutes to get one done. So his first one gets done at 9 minutes. There's his first hair clip, 9 minutes. His second one gets done at 18 minutes. So maybe if I shaded it. So here's his first one. And here's his second one. And for Penny, here's Penny's first one. Penny's second one, and Penny's third one. All right. So when do they both get a hair clip done at the same time?
The 18th minute?
At the 18 minutes, yeah. Does everybody see that? At 18 minutes, they both finish a hair clip, like they're saying right here, finish a hair clip at the same time. At 18 minutes, they both finish a hair clip, right? It's Penny finishing her third hair clip and Sheldon finishing his second hair clip. They both finish a hair clip at 18 minutes. So the answer here is at 18 minutes, they both finish a hair clip. And then how about the next question? After this amount of time, how many hair clips will Penny have made? What do you think?
So Penny does 3 in 18 minutes, and then Sheldon does 2 in 18 minutes.
Exactly, yeah. Penny gets 3 done, and Sheldon gets 2 done in 18 minutes, exactly. Is that all making sense, how we did that problem? Now, I drew it all out, and that's great. You might not want to work that hard every time. So is there a way, let me back up, is there a way we could do this problem more easily without having to draw the whole diagram every time? Well, yes. Actually, look up here at the top. See how it says up here, applications of GCF and LCM? Really, all these questions are going to be GCF or LCM. And do you see right here, it's kind of overshadowed a little bit. See that word least? What is the, let me erase the 12 there. What is the least? 12 back there. What is the least amount of time, or least amount of minutes? Guess what this really is? It's an LCM question, least. In other words, all you really had to do if you want to save time is just take the 6 and break it down, right? The 6 is 2 times 3. So, okay, 6 is 2 times 3. Take the, because that's the first person. Take the 9. You know what 9 is. 3 times 3. In other words, 3 squared, right? And then line them up, right? We've done that in previous homework. 6 is 2 times 3. 9 is 3 squared. Remember this whole thing? Here we go again. Same old thing. Line them up, line them up, line them up. And write LCM. How do I know it's LCM? Least amount of minutes at which they will, same time. That's common, isn't it? Least common. Same time, common, least common multiple. How do you do the least common multiple? Remember, it's highest power for each prime. It's the opposite of the L. That's what's weird, huh? It's least common multiple, but you actually take highest power for each prime. So what's the highest number of 2's? Well, a single 2. What's the highest number of 3's anybody has? 2 3's, right? So the highest number of 2's is a single 2. Highest number of 3's, 2 3's. So it's 2 times 3 squared. It's 2 times 9. It's 18. Sure enough, there it is, 18. So that's all you got to do, is you just got to find the LCM. That's what an LCM, it's where they're first in common. 18 minutes. That's the first time they're going to commonly finish a hair clip, as we see in the diagram, at 18 minutes. And then to answer this question, how many hair clips will Penny have made? Well, 18 minutes, Penny makes one every 6, divided by 6. That'll give you your 3. And 18 minutes for Sheldon, 9 minutes per hair clip for Sheldon. That'll give you your 2 hair clips Sheldon will have done. In those 18 minutes divided by 9, Sheldon will have 2 clips. 18 minutes divided by 6, Penny will have 3 hair clips done. So that's all you got to do, is just do LCM and then divide. Let's try the next question. There's 4 of these. So the next one here is about Catherine and bags of food. Catherine is packing bags of food at the local food pantry. She has 24 jars of tomato sauce, 30 cans of soup. If she wants each bag to have the same numbers of tomato sauce and soup, what is the greatest number of bags she can pack? So do you understand what's being asked? Catherine's got 24 jars of tomato sauce, 30 of soup. She's going to put this into a bunch of bags, but she wants each bag to have the same amount of stuff. Every bag is going to get the same amount of cans of tomato sauce and the same amount of soup. She's Miss Even Steven. So what's the greatest number of bags she can pack? So guess what this question is. Do you see the keyword? Remember this, look up here for a minute. This is GCF and LCM. All these questions are really going to either be GCF, greatest common factor, or LCM, least common multiple. We saw the word least right here in the first problem, and I said, oh, that tells you it's LCM. So what keyword do you see in the second problem, the Catherine problem, that tells you whether it's GCF, greatest common factor, or LCM, least common multiple? Do you see it?
It's greatest.
There it is. Greatest. So it's a GCF question. This is a GCF. That's all you got to do. You got to find the greatest common factor, what the greatest number of bags in common. All right, so what do? We just grab the 24, break it down. 4 times 6, 2 times 2, 2 times 3. 2 to the, what is that, third power times 3. Right, get rid of the 4 and the 6. 2 to the third power times 3. And then we grab the other number, what is it, 30. Break it down, 5 times 6, 6 is 2 times 3. So the 30 is 2 times 3 times 5, right? The primes, get rid of the 6. He broke apart. So we've got the breakdown for the 30. We got the breakdown for the 24. And so then we just line them up like usual over here on the side. So I'm going to go 24 equals 2 to the 3rd times 3 and put underneath it the 30, which is 2 times 3 times 5. And then I am gonna put my lines, line up the primes, and I'm gonna find the GCF for those numbers. Now, this is a little tricky. Pay some close attention here. A lot of people get messed up on this. Remember what we do for GCF. It says greatest common factor, but we actually use the lowest power for each prime. Don't we? Remember from earlier homework that it's exactly the opposite. Back up here for the LCM, least common multiple, we use the highest power. For the lowest, you use the highest. Down here for the greatest common factor, you use the lowest. See how it's opposite? Opposite word, right? For the least common multiple, use the highest power. For the greatest common factor, use the lowest power. Why? Well, because that's what's in common, right? Because it's the greatest common factor. So when it comes to the 2's here, I'm supposed to look at the 2's and say, how many 2's do they have in common? How many 2's do they both share? Just 1 2. See how it's the lower amount? Because that's the amount they have in common. You're supposed to take the lower power. How about when it comes to the 3's? How many 3's do they have in common? Or what's the lower power on the 2 3's? What's the lowest power on the 2 3's? Just a single 3, right? You with me? Now, here's the part that gets people. Are you hearing me on this? If you're cranking through your homework, hear this. This is the part. I was asked several questions about this before. Hear this. What's going to happen with the 5's? What's the lowest? Remember, we're doing lowest. Don't forget. What's the lowest number of 5's one of those two numbers has?
None.
Exactly. None. Very well done. Right? The 24 has none. Right up here. None. Right? None right there. Right? So the common mistake is to just bring down a 5. That's not right. That's not the lowest. The lowest is no 5's, isn't it? Everybody see that? You're supposed to take the lowest for each prime. So what does that give us then? The GCF is just 2 times 3. It's just 6. So that's the answer, 6 bags. Catherine, the greatest number of bags that's going to commonly hold all the stuff is 6. That's the greatest number of bags she can pack. And when she does that, how many jars of tomato sauce will there be in each bag? Well, that's easy. There's 24 jars of tomato sauce altogether, divided into 6 bags. That's going to be 4 jars of tomato sauce in each bag. And finally, last question, if there are 30 cans of soup divided into 6 bags, that'll be 5 cans of soup in each of those bags. So there we go. That's how we do it. So the other ones are the same. See the next question? See the keyword right here, least. So this next one's just LCM. Do the same thing. So that's how all these work. Just look for the keyword. It'll either say least or greatest. If it says least, do the LCM. If it says greatest, do the GCF. Or you can draw a diagram if you want to be more thorough with the whole thing. Questions I can answer.